Morning. I'm going to go through a couple examples of cosecant and secant graphs so that you can work on your 4.6 Part 2 homework. I'll go through the notes on this as well as two examples here, one of cosecant and one of secant. So I just have some notes here. Our 5 key points for the cosecant graph, our endpoints are going to be both vertical asymptotes with another one in the middle. Okay. And then I put these other points as min and max. You can see here I called this one a min because it's a relative min. Everything else goes above that. And I called this one a max because everything else goes below that. Another way you can come up with this graph is you can see here how I drew the sine graph. Okay. This in red here is just our regular parent function of the sine curve. Every time that it goes through the axis, so basically every time sine of x equals 0, because cosecant is 1 over sine, that's where we are going to have these asymptotes, because 1 over 0 gives you a vertical asymptote. And then because they are, it is the reciprocal of sine, we are still going to have these points here. Okay? These points are still going to be the same, but instead they are going to go up and down from those points. The period of these is going to be 2 pi over b for both cosecant and secant. Pretty similar to sine and cosine, as you can see. It does this one shape here from 0 to 2 pi. And it's going to continue to do that shape over and over. Same thing for key points. We want to divide by 4. And our start and end are the same. Bx minus c equals 0. Bx minus c equals 2 pi. Again, I wrote here that these values are going to be affected by your A and D values. If it is shifted up or down or stretched, these might be further up. The middle of our graph might be moved up a little bit depending on those values. Let's see what else we have here. Then for our secant graph, okay. This one's a little different just because it doesn't start with a vertical asymptote. It starts with that min value as I wrote here, and you can see that from if you were to draw your cosine graph. So just knowing these 5 points on that period, you know that your starting point, bx minus c equals 0, that is going to be this min. And your end point at bx minus c equals 2 pi, that is also going to be a min. Right? As we can see that in the graph here. When you go to graph these, you could graph the cosine and then graph secant off of that if you like to. I'll try and show that in the examples, or maybe I'll do one example that way and one example the other way of just graphing it. So I have two examples here. First one being 2 cosecant of x over 2. Okay. I just kind of wrote down some things here before we start, and then I'll graph it here on the video. You can see I did 2 pi over b, which is 1/2. Okay, we need to be careful. Our b value is not 2, it is 1/2. So our period is 4 pi here. And then our key points, we can divide the period by 4 to get key points at each pi value. Okay. So to do the start, I took basically bx because there's no c value and set it equal to 0. Okay. And to solve that, we get x equals 0. And knowing that our cosecant is always going to start with a vertical asymptote with this start point. Okay. And then I just added pi each time until I got to the end of my period at 4 pi, which is also going to be a vertical asymptote. Okay. Looking back at our notes, we see here how I wrote min. But that min is really going to be the positive value up above the axis, and the one that I wrote as max is going to be down here below the axis. Okay. The reason I put 2 and -2 instead of 1 and -1 is this a value. That a value is working as our amplitude, okay. So it is moving that up to 2 rather than at 1. So I'm just going to draw in, okay, we have a vertical asymptote at 0. Pi is going to be up here at 2. 2 pi is a vertical asymptote. Then 3 pi is going to be down here at -2. And I can just continue this process as I know because it is a periodical function. It's going to continue to repeat that same cycle. All right. Then these min values I'm going to draw going down like this, approaching my asymptotes, and the max values are going to go up, or I guess you can call those min values, whatever you want to call them. You can do that here. This one will be here. Another way you could have done this, I'll just do this for this one. 2 cosecant x divided by 2. You could have thought of this and tried to graph 2 sine x over 2. Okay. And what that is this is going to be the reciprocal of this. So if I were to graph this here, all right, period is going to be the same thing that I did. Key points are going to be at the same values. Okay, so I'm going to have these same points, except thinking back to our sine graph, sine is going to start at the top, so sine is going to have a max. Oh, sine is not going to start at the top. That's cosine. Sine is going to start with a intercept, right, or a middle value. Okay. And then it is going to go up to a max, back to the middle, down to a min, and then back to the middle. Okay. So if I were to graph this sine graph, knowing that the amplitude is 2, I know that this point's going to be up here at 2, back to the middle, to a min, back to the middle, to a max. Okay. If I were to draw this curve here, sorry, I'm trying to do this while holding my iPad, so it might not be great. Okay. But as we can see here, if we think about this, okay, we see how every time it goes through the axis, I have a vertical asymptote. And then it also contains all of these max and min values. It just goes the opposite way. So you could graph this by drawing your sine curve and knowing that it's going to be the reciprocal and work from there. Or you could do it just like I did with these points here. All right. For the second one, I'll actually try doing I'll do this with the points as well. If you like doing it the other way, you can do it the other way. As you can see here, I did the period 2 pi divided by b to get pi. My key points are at pi over 4. So I know each of them are going to go up by pi over 4. To find my start point, I basically set whatever's in the parentheses here equal to 0. When I solve that, I get negative pi over 4. And over here, same thing, whatever's inside the parentheses, setting that equal to 2 pi. Solving that, I get 3 pi over 4. This should make sense to us because we see the distance from here to here is pi, our period. Okay. And I can add pi over 4 each time to get these values. Okay. Again, working back to this, I know it's going to be min, vertical asymptote, max, vertical asymptote, min, which is kind of what I did here. Knowing that the mins, because there is no a value or d value, are just going to be at 1, max at -1, and min at 1. Okay. So now I can just put these points here on my graph. All right, 0, we have a vertical asymptote. Pi over 4, we have this point at 1. Excuse me, negative pi over 4. Pi over 4, we have this point at -1. Asymptote. What's next? 1. Asymptote. -1, and it's going to continue this pattern. Okay. And then I just finished my graph by showing it goes to the asymptotes, both on the top and the bottom of our graph. Okay. I know that for the tangent, cotangent, secant, and cosecant graphs, we haven't done much with c values or d values. We are going to do that in the third part of this section. Hopefully from these examples as well as these notes, which I'll post both of these as pictures as well on Google Classroom. Hopefully that helps you to be able to do 4.6 part 2.